Hello and welcome to Technical with Kranti. And today we are into the fifth lecture for the array part of the data structures and algorithms. And today we are going to look into how to sort numbers in O of n. Let's get started. Let's quickly revise what are the different questions we have done till now. So first was setting matrix zeros of the series. Then the second question was Pascal's triangle. Here we learned that how can we construct a row of Pascal's triangle using the row above the current row. The third question was next permutation, which was basically, let's say if you have a sequence of 3 digits, 1, 2, 3, 123, then the next permutation in this series would be 132, 123, and then 132. So how to determine the next permutation for given digits, that we learned how to do that. Then the second last question was finding the sub array which has the largest sum. And yeah, for greater clarity, you can look into the fourth part of the series. And today we are going to look at a very interesting question, which is sort colors, which is basically sorting numbers, because we'll be having one-to-one map of color to numbers. And yeah, let's get started. So there are 3 digits. So for example, uh, this is the input array. Then if 0 represents, let's say, red color, 1 represents blue, and 2 represents green, then you have to bring all the colors together with red in the start, and then blue and green, which is basically sorting the given numbers in the ascending order, right? So we don't have an algorithm that sorts the elements of the array in O of n time complexity. But in this question, we have a little extra information. We know that, okay, 0 and 2 are the bounds on the numbers in the array. And using this information, we can design an algorithm to, to have this ascending order arrangement in O of n time complexity. So let's see how can we do that. In the original question, we have 3 numbers, but let's start with just 2 numbers, right? So here we'll have, okay, so if there are just 2 numbers, we need just one marker that can differentiate between, that can serve as a boundary between the 2 numbers, right? So here we have E0, which is representing the end of 0. I mean, where zeros end. So beyond that, ones start, right? And then there is another pointer which will be kind of used to loop, right? So let's see how are we going to proceed. So if the algorithm is like this, if you encounter a 0, just increment this pointer, because this is representing the end of 0. So if 0 is encountered, just move ahead. But if 1 is encountered, then see, 1 has to go at the end, right? So what we'll do is we'll exchange the E0 and E data, right? And since we have exchanged the data, E0 location will have the data which is not accounted for, right? So what we'll do, instead of incrementing this, we'll decrement the end pointer, because at the end we've already got the favorable number, right? So we'll see. So just at the first location we have 1, right? At the first location we have 1, and what we'll do is we'll swap the numbers and decrement this. So E0 is here only, and we have E over here. Okay, now we have 0 here. We'll increment this, and E0 will come here, and again we'll increment, because 0 is there, so we'll just increment E0. So E0 will come here, then again there is 0, then again we'll increment E0. Sorry, yeah, then E0 will come here, and at this location we have 1. So when you swap it is the same element. E and E0 are the same element, so there is no point of swapping. And E is decremented, so E will come here, and the algorithm will stop once E is less than E0. So this will result in our array being sorted in one pass. So let's see how does the code looks like. What we've done is E0 is at the start to start with, and this is at the end, E, and we'll continue until the end pointer is less greater than or equal to the E0 pointer. And as we see, if the element at E0 is 0, then we'll just increment E0, and otherwise, like if it is 1, then we'll exchange E and E0 elements and decrement this, right? So if we just quickly run this particular program, we'll see this being sorted, right, in O of n time complexity. All right, so let's move ahead and see the case with three numbers. So when there are three numbers and we have to sort them, we need two demarkers, kind of two boundaries, right? One would be the starting of one, and another would be the ending of one, and all the zeros would be before starting of one. So before S1, all the twos would be after E1, and all the ones would be between S1 E1. So to start with, we have S1 E1 over here, and just like the previous case, we have E over here, which represents the end of the array. Now, what is the algorithm, right? So if 0 is encountered, then we increment both the S1 and E1 by 1, and before that we'll exchange S1 and E1. So basically E1 is used to start iterate from here, and if E1 is encountering element at E1 is 0, okay, so we will be exchanging it with S1. Why? Because S1 is the starting of 1, and when you encounter 0 at a later point of time, you will exchange it with S1, because S1 is the starting of 1, and you'll increment S1. I hope it makes sense, right? All right. Now, if 1 is encountered, then we'll just increment the end 1 pointer, which is E1. We'll just increment it because 1 is there. E1 has encountered 1. Just move to the next, because all ones would be in between S1 E1. And when 2 is encountered, then it has to be moved at the end. So whatever we were doing over here in case of 1, we'll do here in case of 2. So what we'll do, we'll exchange the elements at E1 and E, and we'll decrement E. So because at E1 we have encountered 2, right, and 2 is the last element in the given elements, so we'll just exchange it with the last pointer, right, and decrement the last pointer, and will not do anything with E1 because after exchange there has come some element at E1 which has not been accounted for, right? Okay, just digest it. We'll also look into the code. So we have this to start with, and we have encountered 1. When 1 is encountered, just E1 is incremented. So we are over here, right? Now 0 is encountered. When 0 is encountered, then S1 is exchanged with E1. Why? Because S1 is the starting of 1, and if 0 is encountered at a later point of time, then 0 would come at the place of 1 starting, and 1 starting would move 1 point ahead, right? Because before S1 there will be all zeros, and in like placing 0 over here would result in 0 being located with all the other zeros previous to S1, and then S1 is incremented. Okay, so as you can see that 0 is put here, 1 is put here, and both S1 and E1 are incremented by 1, right? Now there is 2. When 2 or the last element of the array is there, then we'll exchange it and decrement E, right? So we get over here. Now here this is 0. So we'll again exchange S1 and E1 and increment both S1 E1. So we are here, right? Now we have encountered 2. So like E and E1 are the same place, so no point of swapping. And E is decremented, so E will come over here and the algorithm will stop. So we have got this sorted over here. Now let's look at the code. So we have this. So it is similar to this thing, right? What we'll just do is, so we need, for three numbers, we need, two boundaries, as starting one, end of one. And this points to the end of the array. So again, the same thing, if 0 is there, exchange the elements at E1 and S1. So E1 is basically used to, iterate. So if the element at the like current value of iterator is 0, then just exchange both of them and increment both of them. If 1 is encountered, just increment this, because between S1 and E1 will be all ones. So if 1 is encountered, increase the gap between S1 and E1, which is happening by just incrementing E1, right? And when 2 is encountered, then just do what we did for 1 over here, which is exchange with the last element and decrement the last element, right? So let's see if our code is working fine. Yes, it is working fine. Now our original question is answered, right? Can this be more generalized? Can this algorithm be used to, sort even higher number of elements? Yes, it can be. So I have done this for 4 nums. So here we'll need, three boundary markers: start of one, start of two, and end of two. Okay. Here what we'll do is, once 0 is encountered, we have to make sure that 0, you know, 0 goes at the start, but 0 is not just exchanged with the, first element. It is exchanged in a sequential manner. So like there are 4 elements, right? 0, 1, 2, 3. So we know that last element would be taken care by this part. So we have 0, 1, 2. So when zero's position in this would be changed, we need to take care that, okay, it is taking care of 1 and 2 also. So here we'll be exchanging firstly with S2, start 2 pointer, and then start 2, S2 would be exchanged with S1. This will ensure that 0 is moved to the starting position and both 1 and 2 have moved towards right? And when 0 goes to its position on the left hand side, and both the S1, S2, and E2 are all these pointers are incremented, right? Now if it is 1, okay, then once say like from 1 only 0 is uh, smaller, right? So what we'll do is we'll be just exchanging, uh, we'll be just exchanging S2, right? Okay, and we'll just increment S2 and E2. Fine. Now, if we encounter 2, which is the second last element, then E2 is incremented by 1. And for the last element, we have this case. All right. So you might be thinking that for 1, we exchange E2, S2, and then S1, S2, right? So all the elements that were greater than 0 are ensured to be moved to right. Similarly, for 1, there is only 2 which is bigger, right? Because 3 is already taken care over here. So we have moved greater than 1 towards right and incremented the pointers accordingly. From 1, only 2 is bigger, so S2 and E2 are incremented. Similarly, for in case of E2, we just increment E2 and that's it. So this is the algorithm for 4 numbers. So let's see if this works fine. As you can see, this is working fine. Similarly, I have made it for 5 elements also, right? So I'll just quickly run it. I'll not explain. The name is, so as you can see, this is sorted. I have also made, like in the example, I did not, in the test case, I did not put one element. I was just trying to see if it will work or not. So it is working fine. So yeah, I hope you would have got some idea. You would have learned how to sort numbers in O of n if you know the lower and the upper bound on the numbers in the array. So yeah, the lesson learned was, yeah, it is possible to sort the numbers in O of n if the upper and lower bounds are known. Please drop in your suggestions in the comment box as to how can I make it more productive. How can we make it, more productive by discussions? Yeah, thank you, and do give it a like. I think today's video was really good. Thank you. Bye bye.